welcome to our second episode of projectile motion. We are continuing with terms used in projectile motion. We had looked at so far 3 terms. We looked at the maximum height, how we get the maximum height reached. We looked at time to reach the maximum height, and we also looked at time for the flight. Our number 4 will be the range, and range means the horizontal distance from the point of projection to where the projectile lands along the horizontal plane through the point of projection. Neglecting air resistances, the horizontal component of velocity remains constant, that is u cos theta, and therefore if we are to determine the range, remember range is the horizontal distance traveled from point of projection to where the object lands. So from our second equation, which says s equals to ut plus a half at squared, we want s x because it is horizontal, so it is sx, which equals to uxt plus a half at squared. But horizontally, we saw that ux is u cos theta and a is 0. Why? Because horizontally the velocity is constant. Then the t will be now the time of flight, because remember, as this object lands, at the point of landing, that's when it has described the flight. So the time considered here is the time of flight. And therefore, if we substitute this in the second equation, we come up with the range. And our range will be u squared 2 sin theta cos theta over g. But 2 sin theta cos theta from trigonometry is equivalent to sin 2 theta. Therefore, our range is given by u squared sin 2 theta over g. For maximum range, we have one condition for maximum range. We have just seen that range is given by u squared sin 2 theta over g. For maximum range, the condition is sin 2 theta must be equal to 1 if we are to attain a maximum range. That's why when you are throwing a stone and you want it to go higher or to travel a longer distance, you always bend. This is the logic, and this is why you always bend when you want the stone to move a longer distance. The condition for the stone to move a longer distance is 2 sin theta must be equal to 1, and if 2 sin theta equals to 1, then that implies that the theta has to be 45. That's why you bend, because you are looking for the angle of 45, which can take the stone far. And therefore, That gives us the maximum range as u squared over g, because 2 sine 2 theta equals to 1, and the 2 theta now will be 90, because for that case theta is 45, then the 2 theta will be 90, and the sine of 90 is 1. That's why we shall have u squared times 1 over g, which gives us the maximum range as u squared over g. Our sixth term is the equation of the trajectory. Trajectory means the path described by a projectile, and this trajectory is expressed in terms of horizontal distance x and the vertical distance y. So for horizontal distance, at any time we saw that x equals to u cos theta t. That is from the second equation, and therefore if we make t the subject, we shall get t as x over u cos theta. Vertically, y equals to u sin theta t minus a half gt squared. And therefore, in that equation, if we substitute for time t, remember from the horizontal motion we got t as x over u cos theta, and then if we substitute for t in the equation for vertical motion, therefore we shall come up with y as x u sin theta over cos theta minus g x squared over 2 u squared cos squared theta. And if we are to simplify this, we end up with the y as x tan theta minus gx squared sec squared over u squared. So that is the equation of the trajectory. We have a hint which says that if a particle is projected directly upwards, the motion it describes is purely kinematic. That is the study of kinematics, is the study of motion under gravity. So meaning that if the body is projected directly upwards, then the motion described is purely motion under gravity. But if it is projected at any angle, then the motion described is parabolic, or it is a projectile motion. In our next episode, we shall start looking at examples under projectiles.